All right, really glad to be here. I have to confess first, being a scientist, I will tell you this is the last place I ever want to be. With all of you out there, I really want to be hiding in an office somewhere with my computer, doing my clouds, doing my little cloud modeling. But they asked me to come out here and tell you about something that is my mission in life, which is climate and climate change. And to give you a little sense of how I got into that, it started for me with Jacques Cousteau in the 60s. Some of you may remember all of his TV shows about the mysteries of the ocean. That made me want to go off and be a physical oceanographer. And I'd already spent 3 years in graduate school going for my PhD when I had the chance to go for a summer program where they brought one of the earliest climate models. This would have been the 1970s. And in that time period, a climate model running on a big computer was something you'd run on your cell phone today. And that model, I added something that you just heard about cloud feedback. Well, what's cloud feedback? Cloud feedback is as I warm the climate, think of global warming, just 1 degree centigrade, 2 degrees Fahrenheit, I change global cloud cover by 1%. If I just change it by 1%, it turns out, I learned that summer, that dramatically changes the sensitivity of the climate system. Think of the volume dial on your stereo. You can turn it up or down depending on what clouds do. That was my epiphany. I had to go back and tell my major professor of 3 years I couldn't do oceanography anymore. I had to leave. I had to go somewhere else. Went to another institute, took up a whole new field, got into clouds, studied that, and I have been chasing the holy grail of cloud feedback along with many people in the science community for the last 30 years. Now, we haven't answered it all yet, but in that process, we've learned a lot of things, and I'm here to tell you about some of those things we've learned. And one of the things we've learned in particular is what I call the 3 laws of climate change. The 3 laws are accuracy, accuracy, accuracy. Now, you all know the 3 laws of real estate, location, 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 right? But these 3 laws actually are 3 different accuracies. One is accuracy of the scientific data we use. We scientists love that one. The other is accuracy of the public information you get to understand climate change. And finally, the accuracy of the policymakers. How do we change what we're doing? So I'm going to tell you a little bit about that today. And I'm going to start that process by giving you a little sense for how the climate system works. You will have a budget at home, you have income coming in, you have expenses going out, you balance the two. The way the climate system works is very similar to that. Sunlight is the incoming resource or energy. That keeps heating up the planet. We have to get rid of it somehow. Often the red on your right is infrared radiation. You actually know what infrared radiation is. You don't see it with your eyes, but you feel it off a fire if you're near it. That's dumping energy off to space. The balance of the two is our budget or energy budget of the planet. That's what determines the temperature of the planet. But then we have these weird things called greenhouse gases. What do? They actually block some of that infrared from getting to space. And when they do that, they act just like you putting another blanket on your bed at night. It's going to make you warmer. The more CO2 we put in the atmosphere, the more blankets we have, the warmer we get. It really isn't that much more complicated than that. So as we study that system, I knew if I wanted to see a 1% cloud amount change, I immediately was going to have to go off and look at satellite data because I couldn't see 1% in the sky out my window. It's way too variable. The weather is too noisy. So we took some of the first satellite data. You're seeing an image of it behind me. From 1965, that's what the globe looked like from the first satellite view of the planet. It's very bizarre to look at. It's got all sorts of weird artifacts in it from mosaicing different times and places together. But now let me fast forward from 1965 to where we are today. That's the world we see from space today. ERA 2000, our new Earth observing system from NASA, satellites orbiting the globe, we see that accurate a view every day of the entire planet. That's why we know a lot more about climate change now than we did in the 1960s. And not only do we look at it in the way we see it in light, but we see it in many different wavelengths. So think colors of light. We can see the green vegetation, the brown deserts. We can see the snow, the ice, the clouds. We can see the thermal emission from the surface in the infrared up to space in the windows. We can see emission from temperature and humidity vertically profiled through the atmosphere. And all that goes together in our understanding of the climate system and how we can predict where it's going in the future. But one of the key things I have to get across to you is the difference between weather and climate. I have been giving climate lectures to the public for 15 years, and this is the first thing that trips everybody up. I get this question, if we can't predict weather more than 5 days in the future, how could we ever predict climate 50 years in the future? And the answer is they're 2 totally separate things. So look at this little chart here. On the left, you see daily average temperatures for right here in Virginia from March 2010. They varied from 35 degrees Fahrenheit up to 60. If I now instead take, and that's the weather we're all used to seeing, try to predict day to day. If I now take the monthly average of Marches for 30 years, that's the middle, and now you see you're down at 9 or 10 degrees Fahrenheit. And if I take global annual temperature, that's the one on the far right, now there's only a range of about a degree over 30 years, and most of that is a trend. It's not actually noise. So now you can see the dramatic difference in which the accuracy we need data. You mentioned accuracy, accuracy, accuracy. The first one I'm going into is the data itself. And now you can get some sense of why climate and weather are two totally different animals. So when we look for accuracy, you already know in your own home life, you really care when you put a thermometer in your child's mouth with a fever, whether that fever was 104 or 101. That's a huge impact to you, so it better be calibrated to within a few degrees. Well, for climate, we need things calibrated for a few tenths of a degree. So let me show you a little bit about how that works. And I have to apologize, I'm showing a chart. I know this is not good. So stick with me here for a minute because there's some really important points on this chart. First of all, the vertical axis is the amount of change of warming per decade per 10 years. So 0.2 degrees C on the left and about 0.4 degrees C on the right axis is what we expect to get per decade in the next couple decades from our best current climate models and where the world's going. This is what the IPCC predicts. What's the IPCC? That's the Intergovernmental Panel on Climate Change. That group is thousands of scientists around the world put together every 5 or 6 years, the best wisdom we have on the planet for where the climate system's going, what our risks are, what our issues are. So they're thinking a couple tenths of a degree. Well, now look on that line for the green line. That's what you'd get with perfect data if you were trying to do climate change. And if you look at a record on the horizontal, that tells you how long a climate record you have. If you only had 5 or 10 years on the left of that chart, your uncertainty in the green line is way up at the same 0.2 degrees we're trying to measure. So if you see something on the internet that says, oh my gosh, since 1998 and the El Nino, we haven't been warming in the last 5 or 10 years, that's somebody who doesn't know climate science at all. That's just noise. The climate system itself has its own noise, but the longer you go out in the record, the smaller and smaller that noise gets. So unlike weather prediction, climate is more predictable the longer we go. It's a very different system. So now, in red, you can see the accuracy of our current weather satellites, about 0.15 degrees C. And in blue, you can see where we want to go in the future, which is 0.03. And now you can see that blue line nicely gets very close to the perfect observing system. And that lets us much more quickly get information on climate change than we currently do. We'll need less time to see what we know and don't know about climate change. So at Langley, one of the new projects we have that I've been excited to be involved in about is called Clario. That's climate absolute accuracy in radiance and refractivity. It's a new observatory where we basically take the kind of accuracy we currently have in NIST laboratories here down the planet and launch them into orbit so that we get much more accurate data up in orbit. That's really critical from what I was just trying to tell you about how we do climate change. And in the future, this will let us raise kind of the whole observing system up in accuracy. So for an example, here's a Google map view of our Clario satellite in purple coming through, making its observations, planning to match in time, space, and angle a second satellite, Aqua, coming through, and actually allowing us to calibrate in orbit other instruments, make them much more accurate, so that all of our observing system gets a lot more accurate than it used to be. This is one of those ground-changing things we hope to do, and our current planned launch date is in 2018. Why do we care about accuracy and where climate change is going? Since we're here on the peninsula, anybody who lives here knows how close we are to sea level. This chart shows you, from the University of Arizona digital elevation map around the globe, if I had a 12-foot sea level or 4-meter sea level rise, what part in red would be covered in water? Most of Virginia Beach, a lot of Hampton, a lot of Norfolk. You can see many of you probably live in places that would be underwater. That 12-foot sounds like a lot. We're not getting anywhere near that fast so far. So is that really where we're going? Well, if I go to that IPCC report, it says depending on how much carbon dioxide we put in the atmosphere, how long you wait for the system to warm up, and how sensitive that volume dial is I talked about, we have anywhere from 1 to 11 foot of sea level rise coming up just from the expanding of the oceans thermally. So that thermal expansion of the oceans alone is going to give us 1 to 11 feet. When you add the ice sheets on top of that, you're going to get more. And the ice sheets, by the way, to show you in the paleo data, the ice core data we have back from 125,000 years ago, we can show the poles were a little bit warmer than now. They're about where we're going to send them in the next 50 years with carbon dioxide emissions. And at that time, sea level was 15 to 20 feet higher than today. That's where the planet wants to go. That's where we're trying to push it. And you should realize we are pushing the planet 100 times faster than a glacial interglacial is pushing it by our orbit around the sun. We are doing something the planet has never seen before. So now let me switch from accuracy of the data to accuracy of public information. And that ties to some of our earlier talks here at TED about the information age and where we're going in it. And what I've got to offer in that particular topic is how difficult it is for many of you to understand. So here's a topic, climate change. This is the worst scientific scandal of our generation. That was just last November in a headline of a magazine. Here's another one. Climate Gate and the Big Green Lie. This is all some scientific conspiracy, according to some people. But yet, actual objective inquiry into that over the next 6 months, while you were all confused as a public about this scientific conspiracy, showed no, there's no scientific conspiracy. As a matter of fact, if you ever worked in the science community, you would realize the last people on the planet capable of conspiracy are scientists. Their entire career is spent trying to prove the other guy's wrong. That's what we do for a living. We revel in it. Do you think we're going to conspire together? Oh my God, we wouldn't dream of it. But yet that's what's sold to the public as why climate is not real. It's just some conspiracy. So you should realize, here's an entire book that's been written by science historians about something called merchants of doubt. Now, what do you mean by doubt? Well, doubt, we all have things sitting here on the internet that tell us, well, is climate change fact? Is it fiction? What's really going on? Is it a political agenda? There are groups out there, you just have to realize, who are making beautiful, scientific-looking websites with the sole purpose of convincing you there's more uncertainty about climate change than there really is. They are merchants of doubt. You, as consumers of information, have to learn how to find accurate information on the internet. This is just like the American Revolution, when newspapers exploded on the world for more rapid, cheap information flow, and initially there was no quality control. There was mostly garbage showing up with strong political agendas. We're right back in that world. It's not bad, it's just we're in a change, and we have to, as a society, to learn how to better quality control the information we have. So how do you do it? Well, the science community has been doing this for hundreds of years. We've learned the way to do this is don't ever trust any one individual scientist. Climate science is so complicated, you can't even trust me, who's been in it 30 years, because I may know clouds, but climate change is oceans, atmosphere, chemistry, biology. You can't get one scientist to understand it. And frankly, most of the skeptics aren't even climate scientists. They're nuclear physicists, or they're chemists, or they're engineers who think they know climate science. Don't listen to them. But how do you figure out then where to go for the right information? The right information comes from places like the American Association for the Advancement of Science. Millions of scientists around the world established in 1850. This is not a recent political think tank. This is scientists who've been spending hundreds of years trying to get the right answers. The American Geophysical Union, 50,000 scientists, started in 1920. The American Meteorological Society. And guess what? While the media may tell you the IPCC has 3 errors in its 3,000 pages of documentation, all of those scientific organizations endorse the IPCC as the best thing out there we currently have. So you do have ways to find accurate information. You can go to these IPCC assessment reports. You don't have to read all 3,000 pages. They have little 20-page summaries you can go to get a better idea of what's going on. You can go to major scientific organizations and their statements that they make, just one-page statements on what they think is going on. You can go to the U.S. Global Change Research Program, basically a dozen organizations in the U.S. that study climate change together as a group. So I've told you about accuracy of the data, accuracy of policy information that you need to get as a public, but then we have to get accurate policy decisions. How do we do that? And one thing we have to realize is this is probably the most difficult challenge society has ever faced. Why? Because all of our genes have been trained over 1 million years to react to very short time scale threats. Lions, tigers, bears, and storms. That's what you and I are trained to do. We are not trained to attack a global 50-year time scale problem. So it sounds at first hopeless, but is it? We actually have evidence 2,000 years ago of actually really long efforts to do things like the Great Wall of China. That's actually pretty impressive, and it wasn't recent. It was a long time ago. We have recent efforts like 350.org actually coordinating organizations and meetings and demonstrations around the globe on climate change. So there are evidences that we can do it, we can deal with it. But now I'm going to bring up what the challenge really is, because it's huge. Think of all of us on this big ship steaming through the ocean, and this is the Titanic. We're out on a new Titanic. It's an incredible ship. It's the most powerful thing ever done. It's speeding through the ocean, but we need lookouts to see what's coming ahead. Well, that's what the IPCC is. They're our group up in the crow's nest trying to figure out, look with long view up ahead, what's going on and where we're going. They've told us we're headed for an iceberg, but we're still arguing about how big is the iceberg and how much damage are we going to get when we hit it. We're not arguing about, are we going to hit something? We're going to hit it. Meanwhile, on the bridge, we have captains, captains. The US, China, India, Europe, all of them trying to argue about which way we should turn the ship, or whether we should turn the ship at all, or whether we should speed up and go faster. This is the level of problem we're dealing with. And remember, we're all in the same ship. There's no other ship we can go to. There's not a rescue ship coming in. There isn't another planet coming up to ours that we can jump off to. This is the only one we've got. We've got to do this right the first time. So we have to be looking out long ahead. You have to think of this as a long-term generational problem, not just today's problem or even next year's problem. You have to think of this as multiple decades. And we have to figure out how we're going to get there and steer this ship in a more constructive direction. So what I'd like to do to summarize that is you need accuracy in observations, accuracy in the information you as a public get, and you've got to have accuracy in policy making, but that will only happen if you guys get accurate information to push where policy is going. And I'd like to summarize all those up with the following quote, which is that man masters nature not by force, but by understanding. And democracies are wonderful, but they only work when most of the people in them understand what needs to be done. And I need all of you to become part of that understanding. Thank you.